Find all vertical asymptotes and create a rough sketch of the graph near each asymptote. So we're looking for vertical asymptotes on this example. So to find vertical asymptotes, we need to write this function in factored form, and the numerator is x plus 6, which is already factored. Denominator is x squared minus 36. This is a difference of squares. We can write this as x plus 6 times x minus 6. And once we write it in factored form, we need to look for common factors. We do have a common factor here. And so what that means, if we have a common factor, that means that we're going to have a hole in the graph. And we can find the hole by setting that factor equal to 0. So this function will have a hole in the graph at x equals -6. And then this remaining factor that doesn't have a common factor will be a vertical asymptote. We can find that vertical asymptote by setting that factor equal to 0. So we have a vertical asymptote at x equals 6. So this function will have a vertical asymptote, just one vertical asymptote at x equals 6. And then we want to create a rough sketch of the graph near each asymptote. So we want to create a sketch of the graph near that asymptote of x equals 6. So I'm going to draw my horizontal axis, which is the x-axis, and mark out at 6 a vertical asymptote. So I'm drawing a little dashed line to represent the vertical asymptote. And we need to remember the definition of that vertical asymptote. As x approaches that value of 6, the y is either going to approach infinity or negative infinity. And we need to consider this on both sides of 6. So we have a special notation that we use to indicate each side of 6. So if we want to say numbers that are less than 6 or the left of 6, we put a minus, and x approaching 6 from above 6 or to the right of 6, we put a plus. So this is going to take care of what's happening on each side of 6. But we know that the y will go to infinity or negative infinity, but we just don't know which one. So we don't know whether we should sketch the graph approaching infinity or negative infinity from above, or if we should approach infinity or negative infinity from the below. And so that's what we need to figure out, which way we should sketch it. So the way we figure it out is with a test value. We want to pick a test value that qualifies for above 6 and a test value that qualifies for below 6. So we could pick, we really want to pick something that's close to 6, so maybe we pick 5.9 and 6.1. We substitute those values into our function and look at the sign. And the sign will tell us whether we're going to go to positive infinity or negative infinity. So we're going to do x and y. We're substituting in 5.9 and 6.1. 5.9 plus 6 over 5.9 squared minus 36. 5.9 plus 6 is a positive number. 5.9 squared is 34.81 minus 36. So 34.81 minus 36, that's a negative value. I'm going to erase this so I can keep writing. So that is a negative value. A positive divided by a negative will give me a negative value. So what that tells me, remember that 5.9 was the number below 6. Because this came out to be negative, that tells me that y will be approaching negative infinity on that side. So that tells me that when I sketch the graph on this side, my y will approach negative infinity. Then I'll do 6.1. 6.1 plus 6, that's a positive. 6.1 squared minus 36. 6.1 squared is 37.21 minus 36. That's a positive. Positive divided by a positive will be a positive. So remember, I chose this 6.1 to be above 6. That plus indicates that I'm going to go to positive infinity. So now I know that y is approaching infinity from above. So I know when I sketch, I'm going to draw it going to positive infinity. So I'm going to zoom out just a little bit. I'm going to draw the sketch one more time without so much clutter. So at 6, that's a restricted value. We know there's a vertical asymptote at that value. Y will approach positive infinity when we're above 6, and y will approach negative infinity when we're below 6. The diagonal of a TV set is 13 inches long. The length is 7 more than the height, 7 inches more than the height. Find the dimensions of the TV set. Make sure to show your work to receive full credit. So on this question, we know that we have a TV set, which is going to be a rectangle. The diagonal of that TV set, diagonal is going from corner to corner, is 13 inches. And we're told that the length is 7 inches more than the height. So I'm going to label the height as x, and the length will be 7 inches more, x plus 7. We want to find the dimensions of the TV set. So in my picture, what I can see is that I have a right triangle. And when we have a right triangle, that means we can use Pythagorean theorem. So Pythagorean theorem says this: if we have two sides, A and B, these are called the legs of the triangle. And then opposite of the right angle, we have C, which is the hypotenuse. And Pythagorean theorem says that the squares of the legs of that triangle are equal to the square of the hypotenuse. The sum of the squares of the legs is equal to the square of the hypotenuse. So we can use that Pythagorean theorem to create an equation which relates the sides of our right triangle. So these two sides are the legs. The side opposite of the right angle is the hypotenuse. So we have x squared plus x plus 7 squared equals 13 using Pythagorean theorem. So this creates a quadratic equation for us to solve. I'm going to multiply out this x plus 7 squared. That's x plus 7 times x plus 7 equals 13. And that's x squared plus 7x plus 7x plus 49. And x squared plus x squared is 2x squared. And 7x plus 7x will be 14x. And I'm going to move this 13 to the other side so that I have all the terms onto the same side. 49 minus 13 will give me a 36, a positive 36, equals 0. I'm going to try to solve this quadratic equation. I'm going to try to solve it by factoring, but if it doesn't factor, then thank you very much. Let me make that correction. Yes, the 13 should also be squared. So then I've got some mistakes to correct here. So 13 squared, I think, is 149, but let me just double check. $169. So then I would subtract 169 on both sides, and this would not be 36. We need 169 minus 49. That gives me a negative 120. Okay, so as I said before, I'm going to try to solve this by factoring, but if it doesn't work, we're going to solve it with the quadratic formula. So I do notice that all of these numbers are even, so I can factor out that coefficient of 2 from every term. That's going to make it a little bit easier to factor. So I have 2 times x squared plus 7x minus 60. And let's see, factors of 60 are 1 and 60, 2 and 30, 3 and 20. 4 times 15, 6 and 10, skipped 5, 5 and 12. Okay, 5 and 12 might work because that could give me the 7 in the middle. So I would need the 12 to be positive and the 5 to be negative in order to get a positive 7 in the middle. So this would factor be x and x, 12 and 5 with a minus on the 5 and a plus on the 12. We're going to set each factor equal to 0. That's x equals negative 12 and x equals 5. And remember that we defined x to be the height of this television set. It doesn't make sense to have a negative height. So we're going to use the height of 5 inches. And that height is 5 inches. And then the length of that television set will be 5 plus 7, which will be 12 inches. So we have the dimensions being 5 by 12. Thank you for checking out my videos. Have a great day.